Hello everyone and welcome to my video on the constant acceleration equations. Now, although it forms part of the specialist maths course here in Australia, I can guarantee you that I've been teaching this for years. And what fascinates me is in the United Kingdom, this is basically weeks and weeks worth of works. And yet we are going to ask you over here to do it in one lesson. Okay, nothing like a sort of challenge. Now, you're up to this, it's fine. What you can see behind me are my learning objectives. Understand where the SUVAT equations come from. Understand how to apply them to questions in finding distance, displacement, speed, acceleration, and time taken for flight. Okay, so this is a massive topic in the United Kingdom, and I'll do what I can. I promise you. If you can do me a massive favor and subscribe to my YouTube channel and head over to mathsguru.com to sign up for free, it would mean the world to me. I get very excited when my videos get like 20 views. It's a bit weird, you know. I'm on Reddit. I know, Reddit. And I read it, and, you know, people are there going, oh, my videos are getting 50,000 views, and it's dropped down to 30,000 views. And okay, I get it. I can't even imagine any of my videos getting 30,000 views. If that happened, I'd need to lie down in a darkened room. Nobody watches maths videos, so if you could subscribe, that would be great. All right, recap of past learning. Now, the last lesson felt like it went on a long time just to get sort of the basics of motion, all right, kinematics going. So hopefully you've watched that video. Again, it's on mathsguru.com. But those of you who've done physics will probably be at a bit of an advantage here. It doesn't mean that people who haven't can't catch up, but you've got all of that sort of past learning to be able to catch up or to be able to do this. And if you haven't done it in physics, guess what? You're going to do it again. Now, the equations are pretty easy to remember. I can't remember if they are on the formula sheet for the VCO exams. If not, just learn them. V equals U plus AT, S equals UT plus half AT squared, V squared equals U squared plus 2AS. Now, there are actually 5 of them, and I can never remember what the 5th one is because it's really just a derivation. So I think it's S equals VT minus a half AT squared. I'll be honest with you, I tend to use those 3 equations all the time because we can pretty much use those 3 to get to what that's trying to get to. Anyway, but it's really important that when you see a question in the exam, if it is talking about constant acceleration, this is what you're going to use. It doesn't work if the acceleration changes, all right? So please. Now, in many cases is applied to questions that do freeform motion or, you know, we throw an object in the air, and so tends to be gravity, and the value of gravity, depending on the question, is generally 9.81 meters per second and squared. It's an acceleration, and gravity pulls things down. So if you throw a ball up, then your acceleration in that situation will be minus 9.8 because it's acting against gravity or it's decelerating by 9.81. And again, if you haven't understood about the positives and negatives and what the signs mean for each of these numbers, I really would go back to my previous video. All right, so there's a few examples. This video won't be massively long. An object is moving in a straight line with uniform acceleration. So this was a SAC question or an exam question. I'd be like, yay, SUVAT. And you're like, huh? They're called the SUVAT equations. Its initial velocity is 12. Now, what we were taught at school, and it fascinates me how often I say to kids over here, this is what you should do, and they completely ignore me, is we were told to write the letters S, U, V, A, and T. Now, that took me all of about 6 seconds. Oh, my life is over. Right? All about 6 seconds, because every time I see something in the question, I put it in. An initial velocity of 12 meters per second. All right? Oops, already put the wrong one in. Now, the difference between U and V are basically, that is my initial velocity, that is my final velocity. And you might turn around and say, well, surely they'll be the same. No. If I throw a ball up in the air, all right, it is going to decelerate uniformly with minus 9.81 per second, but its initial speed, i.e. that which I throw it up with, is not going to be its final speed. Now, final speed's a bit of a misnomer because, you know, a final speed is a speed at a particular point. It doesn't have to be the end of the journey. It could be, well, what's my speed 2 seconds after I threw it up? The chances are that final speed, although it really isn't, yes, will be different from my initial speed. Its initial velocity is 12 meters per second, and it's weird how I interchange speed and velocity there, okay? Speed is basically the velocity, but just the magnitude of velocity has a direction. So if I interchange them, just excuse me. And after 5 seconds, so we now know t equals 5, he says, writing in highlighter, every single time I do that. Its velocity, now in this situation, final velocity, is 20 meters per second. Find the acceleration. So which equation am I going to use to find my acceleration? Well, there is really only one. V equals u plus at. I mean, there's probably others, but it makes more sense to use this one here. So do I know my v? Yep, it's 20. Do I know my u? Yep, it's 12. Plus my acceleration times my time. Now, acceleration in this situation isn't 9.81. Why? Because it's moving in a straight line. So there's nothing about throwing the ball up in the air. So in this situation, we're trying to find a. Take away 20 from both sides gives me 8 is 5a. So a basically becomes equal to 8 on 5 meters per second and squared. Now, is it going to be positive or negative? Again, the question will pretty much work that out for you. But that's pretty much the first part of that question. What's the next one? The distance traveled in the first 5 seconds, right? Well, S is equal to UT plus a half AT squared. Let's see whether we can use that one. That's certainly the one I tend to use all the time. So what do we know? S we're trying to find. U we've got is 12 times T, which is what to do on the first 5 seconds. Yep. Plus a half times A, oh, I've got no choice there, 8 on 5 times T squared, which is 5 squared. Now, in many cases, we try not to use an equation that would build on your previous answer in case you made a stupid mistake. But ultimately, there's only one other formula that we could use, which would be v squared is equal to u squared plus 2as. Again, we know what v is from the question. We know what u is from the question. We're trying to find s, and the only value of a we have is from our question. So either of those would give you the same answer. And when I put this into my equation, I actually get 80 meters. All right, so there we go. So what's the next part? The time taken to travel a distance of 200 meters. Well, in that case, you've got 200 is equal to my initial speed, which is 12 times t plus a half times a, which is 8 on 5 times by t squared. I can't solve that in my head, but what I can do is put it into my calculator. So if we fire up my calculator, he says trying to remember how to do that on here. There we go. So we're going to solve, if you will, please. 200 equals 12t plus a half times 8 on 5. He said doing 87 on 5 times t squared, comma t, hit enter, and what do we get? Minus 25 or 10. It fascinates me the number of people out there who will put minus 25. You can't travel back in time. Oh, hold on a moment. What are we trying to find? The timetable? Yeah, you can't have a minus time. So therefore, in this situation, t would be equal to 10 seconds. All right, the time taken to travel 200 meters is 10 seconds. All right, see, these questions aren't massively stimulatingly difficult. All right, you've just got to be able to pull out the right stuff. It's pulling out things like initial, meaning, t equals 0. Right, next example. A body is moving in a straight line with uniform acceleration. Those are the words I like. Now again, uniform acceleration, constant acceleration, all the same. And an initial velocity of, hold on a minute, Mr. Smith, S-U-V-A and T, SUVAT, that's 6 seconds. I'm never going to get again by writing those 5 letters. Body's moving in a straight line, and initial velocity of 12, we know that's U is 12. The body stopped after 20 meters. S is now 20. Find the acceleration of the body. What? They haven't given me enough information. Yes, they have. Because again, one of the tricks for these questions is the word stop. It stops. If it stops, it's got no speed. So my v becomes equal to 0. Now, having got that, we should be able to find the acceleration of the body. So what have we got? We've got v squared equals u squared plus 2as. We're trying to find the acceleration of the body. Is this equation going to help me? Well, let's have a look. V, do we know what v is? Yep. So 0 squared is equal to u, which is 12 squared, plus 2 times, we're trying to find my acceleration, times the distance I travelled, which was 20. So 0 is 144 plus 40a. So a is basically going to be solvable as minus 18 on 5 meters per second squared. Why didn't you write that in a decimal? I'm going to leave it as a fraction for the moment. Is that it? Is that the question over? Oh, there you go. Easy. Why did that seem easier than the previous question? Here we go again. Another style of questions. A stone is thrown vertically upwards. I love that. Vertically upwards. Right, so there is my ground. from a cliff. Oh my goodness, you've got a cliff. So there's my cliff. So there is my stone. It's being thrown up vertically upwards from a cliff which is 25 meters high. Okay, the velocity of the projection stone is 22 meters per second. So it's going to go up and it's going to start at 22 meters per second. Now we've got to realize at some point it's going to get to a velocity of 0 and find the time it takes to reach the base of the cliff. Oh, sheesh, that is challenging. Okay, lots of ways of being able to do this. Find the time it takes to reach the base of the cliff and give your answer correct to 2 decimal places. Okie dokie. Now, let's see what information they've given me. So we've got S, U, V, A, and T. Right, distance it's travelled. No, don't know the distance it's travelled. I know the base is, I know that cliff's 25 meters high, but I don't know how far it's going to travel to get from here to the top and back down again. Remember, the distance is that whole distance up and then down again added together. It doesn't give me that information. I don't know that distance at the moment. It does not mean it's traveling 22 meters either. U, my initial speed. They give me initial speed. That's 22. V, my final speed. I don't know my final speed. Acceleration. Well, initially, my acceleration is minus 9.8 T. Hold on a moment. I do know a position. And this is where lots of people get a little bit confused because there's so many ways of thinking about it. I know that my position at the start is equal to 0, right? Let's call the origin there. I know at the end of this, it's actually going to have a position of minus 25 meters. Wow. So let's see whether we have information that helps us here. So we've got S equals UT plus a half AT squared. All right. S. Well, at the end of my journey, my S we've now decided was minus 25. So there's minus 25. My initial speed is 22. T. I don't know what my T is, but it wants to find the T. Okay, that's good. Plus a half A. I do know what my acceleration is. My acceleration is minus 9.81. Now you can say, why is it minus 9.81? These values are all initial. And I initially throw that ball up. So it's initially decelerating because gravity, as soon as I let go, is going, come to papa, come to papa, come to papa. That's a horrible thing to have. Where are we now? And then times my T squared. Do I have, oh, well, there we go. Once again, I can now fire up my calculator. And let's see what happens if I put that in. So we've got, what have we got? Solve. Minus 25 equals 22T plus a half times my acceleration, which is minus 9.8, times that by T squared. Sorry about how slow it is. And hit enter. And there we go. Oh, I've got 2 times. It's too confusing. No, it's not, because one of those is negative. You cannot have a negative time. So in which case, it wants it correct to 2 decimal places. So therefore, my value of T is 5.43 seconds. Again, I'm hoping I make this look easy. The point of it is I have done so many of these questions. When I was your age, to be honest with you, I would have done this in a very, very hard way. I would have found the time where velocity is 0. I'd have found that time. Then I would have basically gone, you know, how long does it take to drop from that point forward, and what height was it? And I would, honestly, it would have been disgusting. Life is much, much easier when you realize that you've got an origin here and a position of minus 25 there, and they've given you enough information to help you out. And believe it or not, that's the end of this lesson. There are thousands of questions you can do on this, I promise you. The UK do all of them. So practice. Please, please, please practice. Right, what did we do? Did we understand where the SUVAT equations come from? Yes. Some dude worked it out, and I really don't care where they came from. I just know that they're there, and I can use them. Understand how to apply them to questions to find the distance displacement? Yes, we've just shown some examples. I'm done for this video. Shorter than the last one. If you can subscribe, would be great. If you can tell your friends, that would be great as well. And hopefully I'll see you in another video. If not, take care. See you again. Bye.